Hey folks. Hello folks, it's Michael McDonald again, uh, here with another video. It's been a long time since I made a video on YouTube. Uh, the last time I started what I call the PGI series, which is the Preparatory Ground Instruction series. I've done a few of them, and I'm going to move right along with them. What is PGI? The PGI is basically preparatory ground instruction for a flight lesson. So in Canada, under the Transport Canada regime, we have what's called the Flight Training Manual. And the Flight Training Manual has all the exercises that you go through for your flight training that you can pre-read before the lesson. So once you come in and checked out the airplane and checked the fuel levels and oil levels and everything, and it's time to get down to business, I take the student over to the whiteboard and we talk about the lesson of the day. We do the preparatory ground instruction. So I have my notes here for that. And this particular one is exercise 5, which is the first real flying lesson, attitudes and movements. The objective of attitudes and movements is to demonstrate how pitching the nose up and down and banking the wings left and right and yawing the aircraft left and right, how that affects the performance of the airplane and what you can expect to happen with the airplane when you put those control inputs in. So it's a very important lesson because it's the foundation of all the lessons to come. We emphasize what we call attitude flying, which is looking out the window for your basic airplane attitude information and then cross-checking with the instruments on the control panel on the dashboard of the airplane, the 6-pack, right? So basically the altimeter, the airspeed indicator, the turn coordinator, the attitude indicator, the vertical speed indicator, and the heading indicator. So when you make these various control inputs, then the aircraft will respond, and then you'll see the results through the window, but you'll also see them on the instruments. So that's what this lesson does, and it emphasizes to the students the foundations of flying as they go along with their lessons. So the skills that you learn, pardon me, is the familiarization with controls and the control pressures that you feel and the visual and instrument references. It provides the basis for future more advanced lessons and is the basic reference points from which all flight maneuvers are conducted. So very important. Typically, when I'm doing a PGI or preparatory ground instruction, I'll ask some knowledge questions to see if the student has studied and comprehended the material in preparation for the lesson that we're going to fly. Threshold knowledge test, they call it. So the first question I would ask the students is, what are the 3 attitudes in normal flight? Okay, and they are nose up, nose down, right? Pitch up, pitch down, bank right, bank left, and yawing right, yawing left, all right? So the pitching of the nose is done with forward and reverse control pressure on the control column. The banking movement is created by turning the wheel, deflecting the ailerons, and banking the airplane. And then the yawing is done with the pedals, yawing the airplane. And there are 3 axes that they have to understand that the airplane works around, right? They are in pitch, so these are the wings, nose down, nose up, is around this axis, which we call the lateral axis. Banking is from the forward to the back of the airplane axis, called the longitudinal axis, and it banks around that longitudinal axis. Yawing is around the normal axis, the up-down axis, and that skews the plane left and right from that axes. Okay. Then another thing that I would talk about is how airspeed affects control pressures. Because the controls are basically just flaps or flippers on the airplane, like ailerons, elevator, rudder, then the faster you go, the more air flowing over the controls or over the control surfaces, then the more pressure you feel, okay, when you move the controls. So that's what I would try to determine if they understand these things. All right, so we'll just move right along here. So then we get into the what and how. We've talked a lot about the what, so we'll just move right on to the how. All right. So the first thing we start with is the datum. It's the cruise attitude. Right now I have an airplane cruising along here on this online simulator at 8,000 feet. And you can see that the horizon is horizontal across the dash of the airplane. You can see that it's, well, let's just talk about the instruments first. The six pack of instruments, the basic six pack of instruments that everybody uses, of course, there's now glass cockpits, but they're basically still the same thing, is you have your attitude indicator, and the attitude indicator basically mimics what you see out the window. It's a three-way gyroscope, okay? So the blue area represents the sky, the brown area represents the earth, okay? Also, you'll see there's an orange and white arrow, okay? So when this orange arrow moves left or right, that's indicating a bank, and the horizon would be skewed, okay? So basically, it's showing you what's out the window. So you don't really need it if you're looking out the window in visual reference flight, okay? But you can cross-check it. The next instrument that we can talk about is the airspeed indicator. And you can see right now this plane is doing about 110 nautical miles per hour, and it's constant. And then we have the heading indicator, which is also a gyro. It's a two-way gyro. And it's showing the heading that we're flying. So the direction of flight. Right now, it's about 172 degrees magnetic. Then we have the altimeter, and it's showing a solid 8,000 feet. And then we have the vertical speed indicator, which shows our rate of climb or descent in hundreds of feet per minute. Right now, you can see it's at 0. It means we're not climbing or descending. And lastly, we have the turn coordinator. The turn coordinator is an interesting instrument. It's an electrically operated gyroscopic instrument. And it basically shows the rate of the turn. So if we're turning left, then the left wing would bank down. Or if turning right, the right wing would bank down. And it's showing the rate of turn. The more that the wing is dropped, the greater the rate of turn. And the little ball shows you whether the tail is following the nose in this turn, or whether you're slipping or skidding, which we won't get into in this lesson, but it becomes very important as time goes on. So that's your six pack, 1, 2, 3, 4, 5, 6. This is a navigation aid, we'll ignore that. And this is the RPM gauge, which is not necessary to discuss during this lesson. So let's start with cruise attitude. Okay, it's the datum from which all other attitudes are compared. So cruise attitude, and we just sort of looked at it there, okay? You can see an equal amount of sky and ground, and that the wing level or the level line of the airplane is it's neither up into the blue or down into the brown. So that means that the airplane is straight and level, not climbing or descending. And so that'll give us a constant airspeed because we're not going uphill or downhill. It'll also give us a constant heading on the heading indicator because we're not turning. It'll give us a constant altitude because we're not climbing or descending, and that's reflected at the 0 vertical speed. So straight and level is 90% of your flying is straight and level flight, okay, going from A to B, other than the turns, climbs, and descents. Now, there's a little trick that we instructors teach our students is how, without using the instruments at all, how do you know whether you're in the proper attitude for a cruise? And generally what you do is with the Cessna 172 or a PA 28 Cherokee, if you put your hand up on the dashboard, then your fourth finger should be where the horizon line is. That'll be roughly the cruise attitude of the airplane. If it's a Cessna 150 or 152, then it's 3 fingers, okay? So that's the cruise attitude, the datum from which all other attitudes are compared to. And, pardon me. Okay, so now we'll do the nose-up attitude. So I always emphasize the lookout because we operate in 3-dimensional space in an airplane, not like a car. We are always at the same level on the ground. Here we have up and down. So it's important to look in the direction that you're going, up and down. Now, what I will do is demonstrate to the student what happens to the view and the instrument indications when I apply rearward pressure on the control column, i.e. a nose-up attitude, okay? And I would ask the student, when I get them to try it, to use slight, smooth, continuous pressure of the up elevator. So what's going to happen is we will quickly establish a new reference horizon. And you'll see it out the window. Let's try it. I'm going to pitch this aircraft up a little bit. And watch the horizon. Just watch the horizon right here when I pitch the aircraft up. And give it a couple of... And there you go. The horizon is moving down in the window. Okay? And if you look to the right, you can see the opening angle right here from the wing. And to the left, as long as we're still going up, let me just get a little more up pressure here. You can see the opening angle from the wing. Okay, so that's your climb attitude, all right? That's your climb attitude, all right? Get reset here. Okay, so we'll look at some of the other instruments and what happens when we apply that back pressure. So I'm just going to, again, apply some of that back pressure on the elevator. I'd like you to note the airspeed. Notice that the airspeed is starting to fall off. It's dropping off. And that's because we're climbing up a hill at a constant power setting. So of course, the airplane's going to go slower. So you'll expect to see that the airspeed decreases. Okay? You'll also notice on the altimeter an increase in altitude. You can see we're going up to 8,400 feet here. And the vertical speed indicator will show a positive rate of climb. Let's get her climbing again here. Here we're about 200 feet per minute. 300 feet per minute. So we're down to 80 knots, the nose is up, we're climbing 400 feet per minute. Okay? So that's the nose up attitude. It makes the airplane climb, but the trade-off is the aircraft slows down. Okay? The aircraft actually slows down. So now, we'll switch back to the PGI here. And then what I do is actually, I bring the aircraft back to straight and level. Okay, I bring it back to straight and level. As the airplane speeds up, pressures will get tighter again because when we brought the nose up, the pressures get looser because we're going slower through the air, even though we're climbing. And so once the nose is back at the four-finger cruise attitude, the airspeed builds up and the pressure increases on the controls. Okay, so the next attitude we try is the nose down attitude. Again, control input should be slight, smooth, continuous pressure. And we're going to make the elevator go down, right? Down elevator, or I should say the nose go down. It's also down elevator. So we'll establish a new horizon reference and wing reference. When we do that, let's have a look. Okay, so here we are, stable at about 8,500 feet. We're going a little slow here, just a little glitch in the matrix here. I'm just going to speed the airplane up here. 100 knots. Okay, we'll speed the airplane up a bit. Get it back to speed. Basically, I'm adjusting the power setting and we're bringing it back to speed. So we're back at the cruise attitude, okay? And here we are at 95 knots and we're back to 100 knots. Okay, so what I'm going to do now is I'm going to pitch the nose down, okay? By pushing on the elevator or the control column. So let's do that. Let's see what happens with the airspeed when we pitch. Well, let's talk about the horizon first. So we're going to pitch the aircraft down. Pitching the nose down. Here we go. I'll turn off the autopilot. That'll help. Autopilot off. Okay, so we're going to pitch the nose down. And as you can see now, you've got more ground and less sky. And you can see it reflected also in the attitude indicator. You can see the airspeed is increasing quite a bit. I'm just going to bring the nose up a bit here before we get too out of control here. Oh, I hit the wrong button. Let me just settle things down a bit. Get that set up again. Right, there we go. So pitching the nose down, you see more ground than sky reflected in the attitude indicator. You can see the airspeed is increasing and our altitude is decreasing. And in this case, it's going down a pretty quick rate there, almost 2,000 feet per minute. So we're down to 6,500 feet, very high airspeed. But notice that we're not turning because we haven't put any bank angle in there. So now we're going to bring it back to level. So pitching the nose up slows the airplane down, does not affect the turn, gives you more sky, less ground, and also reflected in the attitude indicator, and a slower airspeed. Pitching the nose down gives you a higher airspeed, more ground in your view, windscreen, a decreasing altitude, and a negative vertical speed. Okay, so those are the nose up and nose down attitudes. Let's talk about the bank attitudes. Again, the lookout's really important because you need to look to where you're turning. You don't walk across the street without looking for traffic. It's the same when flying. Again, the control input should be slight, smooth. And there's one thing that's a little bit different with steering an airplane as opposed to a car is the way that the controls are worked to create the turn. With a car, you hold the wheel in the turn. And then when you're done turning, you neutralize the wheel. But with an airplane, if you were to do that, the airplane would actually do a 360 roll. It would just keep banking because we're banking the airplane, which then creates a turn. So once we have the desired bank angle, we neutralize the ailerons, and the airplane will stay in the bank. To go back to end the turn, we would then bank in the opposite direction until we're level, and then neutralize the aileron. So that's the major difference there. Okay, well, let's give that, we'll have a look here, make sure I didn't miss anything. Right, so we're going to establish the reference horizon. We're going to look at the instrument, okay? Okay, so here we are straight and level. Looks like we're at 6,000 feet roughly, doing about 110 knots, 190 knots. Ooh, let's slow her down a bit. It's a little fast for a Cessna. 110 is even fast for a Cessna. Oh, that's all right. Okay, so what I'm going to do is I'm going to bank the airplane to the right, okay, to my right. And we'll observe the horizon first, okay, the horizon line, and then we'll have a look at the attitude indicator. Okay, so let's go ahead. I'm going to just do it by putting a new heading in here. Okay, so the first thing you'll notice is the airplane banks to the right, about 30 degrees here, and you can see the horizon is tilted, okay? All right. And that once it gets to the proper heading, we then level the airplane and we're on the new heading. All right, we'll try one to the right again. We'll have a look at the airspeed. All right, so we're in the bank, and notice that the airspeed, pardon me, is constant, okay? Because we're not climbing or descending. You can see the vertical speed is 0. Our altitude is the same, okay? Little fluctuations, but for the most part, we are not climbing or descending, and the airspeed is constant. Looking out the right window when we turn right, here, that's too far here. Looking out the right window when we turn right, watch what happens to the horizon, okay? So we'll just, let's see. Watch. See, the right wing is down, okay, during the turn. And the turn is finished, and the right wing is back to level. We can look at that. On the other side, turning right. And we'll turn to the right. 60 degrees, that should be good. And notice that the right wing is now up from the horizon during the turn because the aircraft is banked, and we're turning. And then we're back to level. Now let's look at the heading indicator, okay? The heading indicator reflects the compass heading, all right? It's set against the compass. So here we are, we're on a heading of approximately 60 degrees. Now when I turn to the right, notice that the heading increases. It increases, the numbers increase in our turn. If I turn to the left, notice that the heading decreases in the turn, okay? You wanna get used to that because compass headings are everything in flying. Compass headings and tracks, okay, are everything in flying. And the sooner you get comfortable with the compass roads, okay, from 360, 90, 180, 270, 360, and all the subdivisions within, In other words, if an instructor says turn right 040, you don't want to turn left, okay? Or say you're on north and you say turn 270. Okay, well, that's a left turn, would be the shortest distance to 270 because 270 is west, all right? They're not going to turn all the way around to the right till you get to the west. Understood? Okay, and also during those turns, the vertical speed and the was indicating 0 and the altitude was constant. So that's basically the pitch up, nose up attitude, level attitude, nose down attitude, and then the left bank attitude and the right bank attitude. All right. And then the last one is the yaw. Now, I can't really demonstrate the yaw on this particular software, I don't think anyways. I can have a look and see if it's there, but I don't really see a control for that. If I had the pedals and everything, I probably could do that. But I don't have pedals, so I can't show you the yaw, but we can talk about it. Okay, the yaw is basically, let's get looking out the front of the window here. Oops, that's the back. The yaw is basically around that normal axis, the up-down axis, right? That up-down axis. And the yaw basically skews the airplane with only a slight bank, because every time you, and it's done with pedals, right? Every time you use the pedals, the airplane will yaw, and it will induce a bit of a bank, but mostly that's not why we use the pedals. The pedals are used to coordinate a turn, which is a future lesson, which we won't talk about right now. But suffice it to say that the airplane yaws around the normal axis, okay, the up-down axis. So we've got the lateral axis, pitch up, pitch down, and subsequent movements and views. Then we have the longitudinal axis, bank left, bank right, the subsequent views and instrument indications. And we have the yawing right, yawing left. So the pitch is done with elevator, forward and back pressure. The bank is done with aileron, right and left input, remembering that once you get to the desired bank angle, you have to neutralize it and the airplane will stay in the bank, more or less. All right. And then the yaw, which is more or less just demonstration. The pedals are used for more than just coordinating a turn, but that's a future lesson, which we won't talk about right now. And then we have this little grid here. And there's my little notes on the yaw, right? Control the rudder, watch the nose shift left or right to the point on the horizon, and confirm the instrument condition. Of course, when you do yaw left or right, you are going to turn a bit. So you'll see an addition and subtraction depending on whether it's right or left of your heading. But it's a very sloppy way to turn. Okay. And this is a matrix of what instruments to look at and what to expect. And then we'll just talk about safety considerations. So like I said before, we teach attitude flying in VFR flight. All pilots should emphasize looking out the windows 70% of the time, cross-checking the instruments 30% of the time in VFR flight, visual flight rules flight. Okay. We try not to use excessive pitch or bank angles. It's interesting because there's a lot of input to your body, right? For example, the roaring sound of the wind outside the airplane when you're going fast, the quieter it gets when you're going slow. The pitch and engine change pitches changes in pitch of the engine, and of course the views, right? And one thing that's very important too is that the student and the instructor coordinate as to who has control of the airplane. So if I am taking control of the airplane, I say I have control, and the student releases controls and then says you have control. And if I give control to a student, then I'll say you have control. I release control, release the controls, and then the student responds with I have control. Okay. So that's attitudes and movements. And like I say, it's a very foundational exercise, very important exercise. It's really the essence of flying, okay? It's the essence of flying. Everything is built from that. So it seems pretty straightforward when people read about it, but there's a lot of sensory input things that you would not expect until you get in the air. Like, for example, the pressure on the controls. The faster you go, the more airflow over the control surfaces, the tighter the control column is going to be in the pedals, okay? The slower you go, the looser the control column in the pedals, okay? And that plays in a lot when you're landing, because when you're landing, you're slowing down. Okay, so you need to get used to those pressures and feelings. All right, so that's basically it. Attitudes and movements. And generally, this PGI would take about 20 minutes for me to do on the whiteboard, a little longer here, playing with all the software and everything. And then we go and fly the mission. So that's it for now. So I look forward to seeing you again. And our next PGI, or Preparatory Ground Instruction, will be straight and level flight with speed changes. Thanks, and I hope you have a super day. Bye-bye.